Hello everyone, my name is Mayur Nanajitoke and today I am going to give the presentation on the radio frequency and microwave technology. Introduction. Radio frequency and microwave engineering has an innumerable application from radar example for air traffic control and metrology through electro belt applications example in paper manufacturing and domestic microwave ovens to radiometrics remote sensing of the environment. Continuous process measurements and non-destructive testing, the focus of the course for which this text was written, however, is microwave communication, and so while much of the material that follows is entirely generic and selection and presentation of a material are conditioned by the applications. Figure 1.21 shows that a block diagram of a typical microwave communications transceiver. The transmitter comprises and information sources, a baseband signal processing unit, a modular sum, a intermediate frequency filtering and amplification, a stage of a up convention to the required radio frequency, following by further filtering high power applications HPA and an antenna. The baseband signal processing typically includes one more or all of the following: an antialiasing uh, filter, an analog to digital converter, a source coder, an encryption unit, an error controller, a multiplexer, and pulse sharper, an anti-aliasing filter, and ADC are only required if the information source is analog, such as a speech signal, for example. The modular impresses the process baseband information into the IF carrier, and IF is used because modulation, filtering, and application are technologically more difficult and therefore more expensive than the micro radio frequency. This is the diagram of the information source signal processing modulator BPF and gain. RF devices begin with the review of a semiconductor, their fundamental properties and the features that distinguish them from a conductors and insulators. The role of electrons and holes as a charge carriers in a intrinsic pure semiconductors is described, and the related concept of a carrier mobility, drift velocity, and a drift current and presented are presented. Carrier concentration gradients, the diffusion current that results from them, from them, a drift current presented carrier concentration gradients, the diffusion current that results from them, and the defined definition of the diffusion figure 1.1 typical microwave communications transmitter A and receiver B. Information source signal processing modulator BPF gain HPA gain BPF into BPF up converter A LNA gain BPF into BPF down converter. B information sync signal processing demodulator decision CCT BPF gain overview. 3 coefficient are also examined, and the doping of a semiconductors with the impurities to increase the concentration of electrons or holes is described. A discussion of the semiconductor energy band model, which underlies an understanding of a semiconductor behavior, is presented, and the important concept of a Ferri energy level is defined. This introductory but a fundamental review of a semiconductor properties finishes with the definition of a mean carrier lifetime and outline derivation of a carrier continuity equation, while central role in the device physics. Amplitude modulators. Consider the schematic diagram of a figure showing the transmission line with the vector diode and an inductor connected in a parallel across it. The capacitor CB in is a DC block used for isolating the diode basing for let F be the frequency of the microwave signal at the transmission line input. The inductor is selected in order to resonate with the vector capacitance at F0 for the certain bias voltage. The impedance presented in the microwave signal by the parallel circuit will be infinite for a V equal to V1. For this bias voltage, the signal will be transmitted under unpure unperturbed along with the transmission line. If a diode voltage is now changed to a small value V to around 0 volts, the diode capacitance will increase, presenting a low value of impedance and thus they reduce the transmission amplitude of a microwave signal. This is the figure of an equivalent circuit of a capacitor diode connected in a parallel across a transmission line. The circuit shown in the 2.18 can be used an amplitude modulator by biasing a diode with the average value of VDC equal to V1 plus V2 by 2 and uh, superposing imposing the modulating signal Vm. This is the figure of implementation of a phase shifting using the circular and vector diode. Phase shifters. Vector diodes may be used as a phase shifters by taking advantage of their variable reactance. A possible topology based on a circulator is shown in the figure 2.19 for an ideal circulator. All the input power from a port 1 will be transferred to port 2. If the diode resistance loss is neglected, complete reflection will occur at the purely reactive diode termination. The value of a reactance will affect the phase of a reflected signal. However, by varying the vector bias, the phase shift can be therefore be modified. Finally, the reflected signal is transmitted to port 3. This is the figure where we can see a circuit of a harmonic generation using a vector diode. Forward bias. When connecting an external voltage source as in the figure, the Schottky diode will be forward bias and the reduces the height of a potential barrier to 0 minus V figure. Conclusion: Microwave device modeling and in particular non-linear active device modeling has been an insatiable field of research due to a substantial advantages faced on a microwave transistor technologies. Some of the technologies that have made great impact on a circuit design include a gallium arsenide GaAs, a metal semiconductor field effect transistor, the GaAs, gallium arsenide, and indium phosphide high electron mobility transistor, and GaAs and silicon germanium heterojunction bipolar transistor, the silicon light diffusion metal oxide field effect transmitter FET, and more recently a gallium nitride HEMT. In fact, physics-based model directly derived from the device geometry and semiconductor physics. The equivalent circuit models are both driven by the transistor technology and so have to follow the any technology changes. Thank you.